Hi, I'm Esther. Are you looking for me? No worry, your device is functioning well. I have not turned on my camera. That's why you can see me. Okay, again, welcome to Mr. Class. Let's start our class now. Okay, in chapter 1, we have 3 parts need to go through. 1.1, atoms and molecule. 1.2, more concept. And 1.3, stoichiometry. In this video, we only focus on 1.1. Okay, now let's check out what are the objectives for chapter 1.1. There are 3 objectives. First, we need to write down the isotope notation. Second, we need to interpret the mass spectrum. And number 3, we have to calculate the average atomic mass. However, no worry, in this video, basically we only focus on isotope notation, not the whole chapter 1.1, yeah? Hello, before we go in details in the isotope notation, let's recall what is the meaning of isotopes. Okay, basically in this slide, I'm going to emphasize a few terms with you. Okay, first term is number of protons. Okay, number of proton can be replaced by proton number. Okay, where both meaning for the number of protons and proton number are same. Another term for proton number is atomic number. Okay, what is the next term that we are going to focus is number of neutrons. Okay, number of neutrons can be replaced by neutron number if you are going to define the isotope. However, the meaning number of proton and neutron number are different. Number of neutrons, like the terms lah, it's only referring to the neutrons. But neutron number is the total number for protons and also neutrons. Another terms that have similar meaning with neutron number is atomic mass number. Okay, so I'm going to suggest you stop this video now and write down some notes. Okay, thank you. Okay, let's look at the example of isotope. We have 2 isotopes here. First is the carbon. 2 or more atoms of the same element. So if you look at these 3 are carbon with the same number, same proton number, but different neutron number. Okay, so if you notice what I mentioned just now is same proton number, but different neutron number. Okay. So for the second example is chlorine. Okay, so I'm going to say that here we have 2 atoms of the same element. Both of them are chlorine. Then they have same number of protons, but different number of neutrons. Okay, so here I want to let you know that if you are mentioned about number of protons, okay, then when you continue with the definition, you have mentioned with different number of neutrons. Okay, so this is what we are going to emphasize in this slide. Okay, now let's look at the exercise. Which of the following are isotopes? The first one, A, is not isotopes because there is only 1 atoms. B, yes, is isotope. There is two atoms, and then both these two atoms are same element, which refer to carbon, and then they have same proton number, 6, and also have different neutron number, 13 and 14. Okay, so for question number C, we consider these are not isotope because they are referring to different element. Okay, so D also is not isotope, even though first they are different element. Second, we also notice they has different proton number. So D also not isotope. Only B are the isotopes. Okay, now let's look at the isotope notation. Generally, this is the isotope notation. So basically, isotope notation contain four information. First one is the symbol of element. Okay, like just now we have mentioned about carbon. So the symbol for the carbon is C. Okay, second information that we are going to have in the isotope notation is known as neutron number, which represents by the symbol of A. But basically, the neutron number, like just now we also mentioned, it also can known as atomic mass number. But in this slide, they also use the term mass number. Okay, the third information is the proton number, or also can known as the atomic number, which in the general isotope notation will be represented by Z. Okay, so for me, I will remember from the top to the down is A to Z. Okay, AZ. Okay, the last information that we are going to get from the isotope notation is the charge of the ions. Okay, the charge can be positive and also can be negative lah, as what we already know. Okay, basically here we can be simplify just a reminder only. The A neutron number, like what we know just now, it is represented by the total number of protons and also total number of neutrons. If I want to get the number of neutrons, then I'm going to use A minus Z from the isotope notation. Okay, after having the idea of the isotope notation and recall back the definition for isotopes, I think this is the time that we're going to do tutorial question. So here I only will discuss tutorial question 1 until question 4 because this 4 question is related with the isotope notation. However, like in question number 1, I think I'm going to discuss question number 1, number 4 and number 6 with you. Okay, before we start answering the question, we have to read the question as usual. State the number of subatomic particles. So the subatomic particles basically is referred to protons, electrons, and also neutrons. Okay, so I'm going to use the symbol P, E, and N to represent proton, electron, and neutron. Okay, so look at the first question. You are given the isotope notation for sulfur. So this is the Z, which represent the number of proton. Because of there is no charge here, so means that number of proton and electron are similar. How to get the number of neutrons? We are going to use A minus Z. So 32 minus 16. So it will be 16. Okay, the next question that we are going to discuss is fluoride ion. Proton number for fluoride ion is 9. Okay, no worry, you no need to memorize this number. During the tutorial class, I'm going to let you know how you can get this number when you want to do the tutorial question in the future or when you want to answering the question in your exam. Okay, so like just now, this 9 will be represent number of proton. but then here is negatively charged. Means that fluoride ion has extra electron compared to proton. So extra how many? Extra 1 only. That's why the charge is 1 minus. Okay, so number of electron will be 10. And then the number of neutron, 19 minus 9, so will be 10 as well. Okay, the next one is the chloride plus. So as we all know, chlorine, the proton number for chlorine is 17. Okay, so in this case, again, the proton number similar with number of protons, so it's 17. So in this case, the charge is positive. So means that in this ion contain more proton than electron. So that's why we are going to minus 1. So the number of electron is 16. While the number of neutron is still the same, 37 minus 17, so equal to 20. Okay, so the rest of the question, you try to answer it yourself. Okay, now let's look at question number 2. Write the isotope notation when the following species is given the subatomic subparticles number. Okay, so in this question, okay, I will going to choose V and Y to discuss with you. So as we already know, isotope notation consists of 4 information. The first one is the symbol of the element. So in this case, it's V. And then we have to have proton number, which is 7. Then we look at the neutron number, which is 7 plus 8. Total will be 15. Okay, then the last information is about the charge. So proton is positively charged, so I'm going to put positive sign here. Electron is negatively charged, so I'm going to put negative sign here. Okay, so positive 7 plus negative 7 is going to 0. So if there's no charge, we will no need to put 0. Here is okay. So next one is the Y, species Y. Okay, so first we have the symbol of Y. Second, we put the proton number. Third information, we total up the number of proton and neutrons to get neutron number. Then the fourth information is about the charge. There is 22 proton while 18 electron. So when I total up positive 22 with the negative 18, I will get positive 4. So when we write down the charge, we are going to start with the number, then only give the charge positive or negative lah. So in this case, because it's positive 4, so we will write down 4 positive. Okay, so the rest, try it out yourself. Okay, now let's look at question number 3. In this question, you look at it, they give us a incomplete isotope notation, and then they have give us some information, 34 protons and 45 neutrons. So let's use this information, try to make it more complete. So we have G, 2 negative, 34 protons, so I'm going to put 34 at the bottom here. Okay, and then the neutron number is total up protons plus neutrons. So 34 plus 45, so it's 79. Okay, so based on this information, I can get this complete isotopic notation, which is actually this question. Okay, then they ask us to determine the number of electrons. Like just now we mentioned, 2 negative means that this ion G have more electron than proton. Extra how many? Extra 2. So that's why 2 negative plus 34. So I will get 36 electron. Okay, then they ask us what is the neutron number. So basically we already total up just now lah. So the neutron number is equal to 79. Okay, now let's look at question number 4. You are given the atomic structure A until D, which they are represent atoms of ions. When we look at the table given here, all the symbol of A and D, A until D doesn't show any charge. So this doesn't mean all of them are atoms. We have to figure out ourselves. So basically, we are going to compare the number of electrons and neutrons. So for the A, they are same. So there is no charge for A. Similar case goes to the B. So B also have no charge. While for the C, they have 12 proton and 10 electron. So I know C will be 2 plus. D also the same case. There is similar number of protons and electrons. So D also is an atom. Okay, so when you're answering this question, you just can use the letter A to D. Okay, so that's mean like C2 plus, we are not accepted. We only accept C only because they say use the letter A to D. Okay, so next one, they are going to ask us to choose two particles, are atoms and ion. So before I finish this question, I think basically all of us already know that C will be part of the answer. Why I say like this? Because just now we already go through A until D, only C with the charge. So when C with the charge, C will consider as ion. Okay, so now we are going to look at the second part of the question of the same element. Okay, so basically if they are referring to the same element, basically they always will have same proton number. Okay, then we try to look at C. Which particle else has same proton number with C? So it's very obvious, is B. So your answer here will be C and B. Okay, but let's say you don't like, you think that C and B is a bit weird. Okay, so you can write it down, B and C also, no problem. Okay, so now we continue with the second question. Choose again two particles, and then they are isotopes. So again, what is the definition of isotopes? They are going to have same proton number, but their neutron number is different. Okay, so when we look at here, seems like we can have B and C as one choice because just now we already noticed they have same number of protons. But then when we look at B and C, the neutrons also same. So means that they didn't fulfill the requirement. They fulfill same proton number, but they didn't fulfill the different neutron number. Okay, so means that B and C is not the answer. So now we try to look at what are the possibility. So we can look at here, A has 6 protons, D also have 6 proton. Okay, then A have 6 neutron, D have 8 neutrons. So different number of neutrons. So the answer for second question is A and D. Okay, we already finished question number 4. Okay, this is the exercise that you are going to do it yourself. I hope you can get the answer besides completing the question 1 and question 2 from the tutorial question. So this is the extra exercise for you. And then you also, okay, after finish the exercise, you may check out a few common mistakes that made by students through the link below. And then if you have any questions, we are going to discuss in the tutorial class. Okay, so that's all. See you again.